Hello there. Have you ever looked at a map and wondered why the UK isn't buried in snow for half the year like parts of Canada are? I mean, we're on the same latitude. The secret lies deep in the ocean, in a huge hidden engine that basically runs our planet's climate. Today, we're going to dive into what that is, how it works, and why its future is so incredibly important, especially for us. So, here's the plan. We'll start with that weird climate puzzle. Then, we'll uncover the giant ocean conveyor that's behind it all. We'll break down exactly how this natural heating system works before looking at the pretty serious threats it's now facing. And to finish, we'll see what all this could mean for the future of the UK's weather.
Right then, let's get straight into it with this climate mystery. It's a classic environmental science puzzle and one that you've probably thought about yourself. Why is Britain so, well, mild?
So let's put the question out there, nice and simple. Why isn't the UK as cold as Canada? It feels like it should be, right? But the answer takes us way out into the middle of the Atlantic Ocean. Just think about this for a second. We share the same latitude as places like Churchill in Canada, which is literally famous for its polar bears, and Moscow, known for its brutal winters. And yet, we get off pretty lightly in comparison. So what gives? What's our secret? Well, the answer isn't in the air above us, but deep down in the ocean. It's time to meet the colossal hidden heat engine that shapes our world. The best way to picture it is as a massive global conveyor belt. And no, this isn't science fiction. It's a very real system, constantly shifting mind-boggling amounts of water and, most importantly, heat all around the planet. Okay, time for the proper scientific term, and this is one you'll definitely want to remember for your exams. It's called thermohaline circulation. It sounds a bit complicated, but it's super logical when you break it down. Thermo is all about temperature, and haline is about saltiness, and it's those two things working together that drive this whole incredible system. All right, so we've got the big global picture. Now let's zoom right in on the part of this system that directly affects us here in the UK and across Northwest Europe. You might have heard of it before. It gets called a few different things: the North Atlantic Conveyor, or often just the Gulf Stream. Whichever name you use, it's essentially the same thing, a vital current that acts like a giant hot water bottle for the UK. So how on earth does it work? Well, it all kicks off down in the tropics, where warm, really salty water starts flowing northeast towards us. As it gets closer to the Arctic, it gives off all that lovely heat, which warms up Europe. But in doing so, the water itself gets colder. Now, this cold, salty water is much heavier, it's denser, so it sinks, plunging deep into the ocean. And that sinking motion is the absolute key. It's like a giant plug hole, pulling more warm water up from the south to fill the gap, which keeps the whole conveyor belt moving. So just to quickly recap, you've got two main things powering this whole operation. Firstly, you've got the winds blowing from the southwest, which give the surface water a good push. But the real engine room is that powerful sinking of cold, dense water up near Greenland, which creates this massive pull that drives the whole current. It's an amazing, elegant system, right? But, and this is a really big but, that delicate balance is now under a huge threat from climate change. And the main culprit can be summed up very simply: melting land ice from Greenland. Here's the chain reaction, step by step. As our planet warms up, Greenland's massive ice sheet melts. This dumps enormous amounts of fresh water into the North Atlantic. All this fresh water then dilutes the sea, making it less salty. And here's the crucial part. Less salty water is less dense. It's not as heavy, so it doesn't sink like it's supposed to. And if that water stops sinking, the plug hole effect gets weaker, and the whole conveyor belt starts to slow down. So, let's bring this all back home. What does this actually mean for us? If our warm water delivery service starts to fail, what would that look like for the climate here in the UK? Now, this is where it gets really strange. You'd think global warming means everything just gets warmer everywhere, right? Well, not necessarily. The shocking outcome is that the UK could actually face regional cooling. If that warm current gets weaker, we lose our hot water bottle. The direct impact would likely be much colder, harsher winters and cooler summers. Basically, our climate could start to look a lot more like the other places on our latitude. But, and for those of you aiming for the top marks, this is an absolutely crucial point. It's not that simple. Climate science is incredibly complex. While a slowing conveyor belt points towards cooling, other massive systems like the jet stream high up in the atmosphere are also changing, and they could push our temperatures up. These systems all interact in ways we are still trying to fully understand. So the future isn't set in stone. And that's really the big takeaway here. The North Atlantic Conveyor is just one massive cog in an incredibly intricate global machine. Seeing how vulnerable it is really highlights just how interconnected everything is. And it leaves us with a pretty daunting question, doesn't it? What happens to the whole machine when one of its most important pieces starts to break?